Welcome to Calculus Chapter 2, Section 2, the limit of a function and limit laws. This is the first topic in calculus. Super important. It's used quite a lot all the way through the Calculus 2 course that I taught. So what the heck does this symbol mean, limit? What is this? So basically, it is a symbol that looks like this. We're asking, what is the limit as x approaches c of f of x? Is the function f of x approaching some y value L as x approaches c? So when you're writing your limit, first of all, this is telling you as x approaches c, from both sides, so from the left and also from the right, what is the y value? So are we approaching some y value L? Now, we never have to get to L. We just want to be able to say what we're approaching. So let me give you an example of this. The limit as x approaches 1 of the function x plus 1. So what we have drawn here is the line y equals x plus 1. And they're asking, as x approaches 1, so if you were on this function and you were kind of riding the function and you're approaching x is 1, which I guess is right here, as you're approaching 1 on this side, you can see that the y value is approaching 2. And that's the same if we ride the function in the other direction. So if I approach x is 1 from the other direction, I can see I'm getting to the same y value. So the answer to this would be 2. So that's graphically what's happening in a limit. Here is a picture of y equals x plus 1 squared. You can see it's a parabola. It's for x is negative 1, 0. And this is asking you to have x approach 1 again. It's not always going to say x approaches 1, it'll say x approaches other things. But in this case, it's talking about as x approaches 1. So if you look at your function and you're riding your function coming in on the left, you can see that you're reaching some y value. And then the same in the other direction. As you approach x is 1 in the other direction, you're getting to the same place. Both ends are pointing in the same direction. They're both pointing to a y value of 4. So that's the answer to the limit. So this is graphically what happens. Again, here is the picture of x squared minus 1 over x minus 1. And so again, we're looking for when x approaches 1, what y value are we approaching? And you can see that we're approaching 2. Now, you may question on this one. Like the first one, oh yeah, clear that that's a line, right? Y equals x plus 1 is a line. Y equals x plus 1 all squared is a parabola. But why is this weird function, this rational function, making a line? Well, you probably remember historically about this function that it actually can be simplified, right? Because in actuality, x cannot equal 1, because that would make the denominator equal 0. So I can say that this function is actually approximately equal to x plus 1 times x minus 1 over x minus 1. So I can factor the top. And the x minus 1's cancel, and you're left with x plus 1. So it's actually graphing as a line, except we know that this line is actually going to have a hole at 1, 2. But even though there's a hole there, we can see that we do have a limit, because as you are approaching x is 1, your y value is approaching 2. There's no actual point at 1, 2, but that doesn't matter in the case of a limit, because a limit is just what are you approaching for a y value. Likewise, I have a piecewise function here. So the line is showing exactly what we were talking about in the last problem, because it's the same rational function. We now know from our discussion that there's actually a hole at 1, 2, and this picture is not really reflecting that, because a hole is very, very small in actuality. It's just a minuscule point around an infinite amount of points. But we could draw this picture with a very sizable hole there, just so people can see it. And then this piecewise function is filling in the hole, not at 1, 0, but at 1, 1 is where this dot's supposed to be. So this is a graph now of the piecewise function. We can see we have a removable point. But even still, if I'm asked to find the limit as x approaches 1, what it's asking for is, as you approach x is 1 in this direction, what is the y value that you're approaching? And you're approaching the y value of 2. And the same thing is true in the other direction. If you were walking along this curve and you're walking towards x is 1, your y value is approaching 2. It doesn't matter that your actual point is in a different place. The limit would still be 2, because that's what you're approaching on both sides of 1. That's different than if they asked you for what is g of 1. Well, that's a different story. G of 1 is actually equal to 1, because that's where the point is located. One more thing I need to say about this page. You may also notice that you could also use substitution as a method to solving limits. So what I'm saying is that this is the equation f of x equals x plus 1. And if they're asking you about what happens as x approaches 1, you could always see if you could just substitute x as 1 in and get an answer. See, you get the same answer. Likewise, in this particular case, if I were to take my f of x is x plus 1 squared. And if I were to say, oh, well, what is f of 1? Because that's what I'm having my limit approach. And I can see I can still get the answer 4. So sometimes substitution works. In this particular case, substitution would not have originally worked, because it would have made 0 in the denominator. So as the function originally stood, x squared minus 1 over x minus 1, you would have 0 in the denominator if you plugged in 1 for an answer. So it would be undefined. So that is your tip, that you can then possibly reduce the fraction and then take the resulting function and now find the limit as x approaches 1 of x plus 1. And now substitution works. So sometimes substitution doesn't work immediately, but it works if you simplify the function.